Number 59 says when serving in tennis, a player tosses the ball vertically, and it gives us the height of the ball as a function of time. Part A wants to know how high the ball goes in the air. So the ball, notice the C value in the quadratic is 0. The ball starts at a height of 0. If I plug in 0 for time, I get 0 for height. So it starts on the ground, and over time it goes up and comes back down. Notice the highest point is going to be at the vertex. So when it asks how high in the air does the ball go, we just need to find the vertex. The vertex can be found by negative b over 2a, giving me negative 7 divided by negative 10, which is 0.7. Remember, this is the x value of the vertex, or in this case, the t value of the vertex. So that is a time measured in seconds. It's asking for a height. So plug 0.7 back in for time, the height at time 0.7, and we can use our calculator to evaluate that. And I forgot my x. I get 2.45, and looks like our units of height are meters. There it is. Part B, assume that the player hits the ball on its way down when it's 0.6 meters above the point of the toss. For how many seconds is the ball in the air between the toss and the serve? So the ball goes up, and when it's on its way down, but its height is 0.6 meters above the ground, that's the point we're looking for. How much time has passed? So we want height to be 0.6. So 0.6 equals negative 5t squared plus 7t. We solve quadratics by getting them equal to 0. Our best option in solving this would be to solve it by graphing. So we graph y equals negative 5x squared plus 7x minus 0.6. Zoom standard to see the basic graph. And there we go. I am going to change my window a little bit so we can see a little bit better what's going on. I'm going to go from negative 1 to 4 seconds, and from negative 2 to 3 meters, because remember, max height's a little less than 3. So we've got a little better idea on what's going on here. So remember, we start at time 0. Notice it passes through 0.6 seconds, which makes sense, or I'm sorry, 0.6 meters at some point here. But remember, we're looking for when the ball is coming down and at 0.6. So we're looking for the second x-intercept here. So this one right here. And we can calculate that by going to calculate second trace. Number 2, which is 0, it is definitely in between 1 and 2. So my left bound is 1 and my right bound is 2. When it says guess, there's only one x-intercept in there, so I can just push enter again, and I get 1.308. T equals 1.308 seconds.